soaring through the skies with its propellers whirring at incredible speeds. This defense aircraft boasted a unique capability: vertical takeoff and landing. Designed to be a pivotal asset for the Navy, it was meant to shield any vessel in the fleet and herald the age of helicopter-like planes. However, this vision was never realized. Join us as we explore the story of the forgotten Martin Model 262 Convoy Fighter. World War II exposed a critical vulnerability in the US Navy's strategy. Their convoy ships, essential for resupplying fleets, armies, and bases worldwide, were highly susceptible to enemy air attacks. These convoys required extensive protection from warships to ensure their cargo reached its destination safely and on schedule. Defending these convoys proved challenging and allowed enemies to divert significant naval resources. Haunted by their wartime experiences against the Nazis, the Navy feared the Soviets would adopt similar tactics against Atlantic cargo ships if the Cold War escalated. Thus, they sought a new kind of aircraft, one with the power of a standard fighter interceptor, but capable of vertical takeoff and landing, VTOL, eliminating the need for a carrier. In 1949, the US Naval Bureau of Aeronautics initiated a competition to create this innovative convoy fighter. This aircraft needed to launch from smaller vessels and provide protection until a carrier could arrive. Dubbed the VF, for Convoy Fighter, the plane had specific design requirements. It needed to take off from the deck of a convoy ship, reach near supersonic speeds at 45,000 feet, and ascend from sea level to this altitude within 5 minutes. Additionally, it would carry a single pilot in an ejectable pressurized cockpit, perform combat missions for at least 100 minutes within a range of 100 nautical miles, and return to the original ship for rearming and refueling. To achieve the best design, the Navy enlisted 5 different aircraft contractors. The Glenn Martin Company of Baltimore, the hero of our story, was one of them. Competing against them were Lockheed, Northrop, Convair, and Goodyear, each presenting their unique designs and concepts. Among these was the Convair Pogo, which we've previously covered. With such formidable competition, Martin needed an exceptional idea to secure the contract. This idea was embodied in the Martin Model 262. It consisted of 3 distinct turboprop fighter designs, each with unique features. Named A, B, and C, these designs primarily differed in the placement of the propeller. Interestingly, the propeller wasn't necessarily positioned at the front of the plane. For instance, in Design C, the propeller was located near the tail, behind the pilot and main fuselage. This configuration provided a better center of gravity and required a smaller tail, enhancing visibility for the prone pilot, though it presented significant engineering challenges in connecting the plane's 2 halves with a propeller. Design A followed a conventional aircraft layout, offering excellent endurance and being the lightest among the 3. Design B, however, focused on better stabilization and improved firing accuracy by positioning the propeller at the center of gravity. Martin planned to conduct further wind tunnel tests to determine the most promising design for development. The Martin Model 262 was not intended to be a mere scout plane. It was designed to carry significant armament, including 2 20mm cannons mounted on the wings, with ammunition loaded through top-mounted doors. Additional weaponry, such as rockets or early missiles, could be attached under the wings for interception missions. Had the aircraft been built and remained in service, Sidewinder missiles would have likely been an ideal choice for armament in later years. To accommodate its hovering ability, the plane needed a significantly smaller tail to prevent gusts of wind from pushing it off course during landing or causing it to collide with the ship it aimed to land on. To facilitate these landings, the pilot's seat could rotate 45 degrees, providing an excellent view through a specially designed window in the fuselage. The landing process itself was quite extraordinary. Martin quickly realized that the real challenge wasn't takeoff, but the complex nature of landing. The Navy initially assumed that the Convoy Fighter's pilot would have perfect conditions and control during landing. They imagined the pilot could effortlessly land the aircraft on its tail on a small deck patch, even while the ship rolled 15 degrees side to side and pitched 4 degrees forward and back. Martin, with its practical experience in building and testing airframes, recognized this scenario as unrealistic. Instead, Martin anticipated some of the worst possible conditions: a storm, a stressed pilot, and the chaos of combat missions. They designed their 3 concepts to land not on the deck, but on a specialized platform attached to the ship's side. This approach meant the pilot only needed to match the ship's speed, without worrying about its pitch or roll. A crew member, unencumbered by flying the plane, would operate a stabilized platform to catch the plane as it hovered vertically. This platform would cancel out any rolling of the sea. The plane would then deploy a vertical spike to latch onto the platform. The pilot could view this process through a window in the floor, ensuring precise alignment. Once the spike was secured in a 10x 10-foot area, arresting cables would catch and stabilize the plane. If the initial attempt failed, the design allowed the plane to bounce back for another try. After securing the plane, the platform would rotate it horizontally for rearming and refueling. In adverse weather conditions, the Model 262 was equipped with a small radar beacon to assist in landings. This beacon transmitted the plane's position to a TV screen at the platform, helping the operator guide the pilot accurately. The platform could adjust the aircraft's pitch and location as needed to ensure a safe landing. For takeoff, the process was reversed. The pilot would start the engine horizontally, and the aircraft would move off the platform into the sky once it reached a vertical position. This innovative design allowed nearly any Navy ship to carry convoy fighters with minimal modifications, even those lacking deck space. For land operations, a specialized truck was designed to transport the platform. With the design refined and the landing issues resolved, Martin was ready to enter the competition. Given the unprecedented nature of this aircraft, Martin planned an extensive wind tunnel test phase and intended to develop 2 small weaponless prototypes based on the A model to test the concept. They also revisited their landing system, exploring alternatives such as a platform that moved counter to the waves, similar to modern helicopter landing systems on naval vessels. Confident they had addressed all potential issues, Martin headed to Washington. However, Martin's commitment to multiple options became their downfall. When presenting to the Navy, they showcased 3 different models, A, B, and C, a prototype airframe that differed from A, and various alternative landing systems. They also struggled to provide a definitive budget, candidly admitting the project could exceed initial cost estimates. This lack of confidence unsettled the Navy. Additionally, the projected weight of the aircraft became a critical issue. Martin estimated their aircraft would weigh 16,000 pounds, while the Navy's estimate was 17,500 pounds. Martin's insistence that their design was superior, despite these discrepancies, further dissuaded the Navy. Ultimately, the Navy opted for the lighter designs from Lockheed and Convair. Consequently, the Martin Model 262, with its unconventional propeller configurations and ambitious design, was relegated to the annals of lost aviation history. What if the Navy had chosen Martin's unconventional approach? What other groundbreaking technologies might be waiting in the wings, ready to reshape our world, if only given the chance? If you enjoyed this video, kindly hit the subscribe and like button for more. Don't forget to turn on the notification bell so you will be notified when we upload new videos. Thanks for watching. See you in the next video.